Assalamualaikum and hi everyone. We are Group 2 will explain about monoid, a part of semi-groups in this chapter. Before we start, let me introduce our group members. Let's start with the definition of monoid. Here, given a set S, a monoid is a semi-group S asterisk that has an identity. A set S that assembled with a binary operation, Cartesian product of S and S to S is a monoid if it satisfies these two axioms which we have already learned at the beginning of this chapter. First is the associativity of the binary operation, and next is the identity element where there exists an element E in S such that for every element A in S, the equalities of the binary operation hold. Let's look some of the examples of monoid. So this is for the matrix. The n times n matrices over the integers with matrix multiplication is a monoid. So let's take n is equals to 2, so we have 2 times 2 matrix, and let A and B be the two matrices. First, we prove for the associativity for the matrices, and remember that this involves multiplication of matrix, so we just multiply all 3 matrices, and here we prove that the matrices are associative. Next, we prove for the identity element. Here, we multiply matrix A with the identity element. We still get the same matrix of A. Then, we check for the equality between A asterisk identity matrix and vice versa. So, it is shown that it has the identity element of identity matrix where 0 and 1 is in the integer. Recall back the properties of multiplication of matrices. The first 2 points is same as the axioms of monoids for the
This is an example of monoids. The sets of positive integers with multiplication operation is a monoid. The set S equal to 1, 2, 3. This is excluding 0. Here, closure hold S for every pair A, B in element of S, which is A times B is the present of set S. As we can see here for the examples, when we let A equal to 1, B equal to 2, and then we times the two of them, and then we get the answer in elements of S. Associative for every element. A, B, C in element of S, which is in bracket A times B times C equal to A times in bracket B times C. That means for the examples, when we times 3 numbers, even the bracket is changed, it will get the same answer. Identity for every element A in element of S, which is A times E equal to A. When E equal to identity elements, where identity elements is equal to 1. For the examples, 2 times 1 will be equal to 2, and 3 times 1 will be equal to 3.
We go to the last example. Firstly, Z plus with the identity element 0. Second, ZX with the identity element 1. Third, PS union with the identity element empty set. Fourth, PS intersect with the identity element S.